we're going to come back to this definition in a moment, but this is how you define equality of matrix. This is an example of what you were asking was what happens if you have different names of entries, but they're connected in some way. And we'll sort of use that to define things, and then that will be part of the way of saying, okay, we have two different specifications of matrices with Aij and Bij, and they're the same matrix. So what this means is that equality of matrices is these are just two different names for the same matrix because they have the same entries. Okay, let's see. Does that?
Yeah.
Okay, so if we look in the text here from the beginning for matrix arithmetic, this is what we've just gone over here. So here's a matrix A. We have rows, columns, and entries, and we have like the A is the matrix of entries Aij, and we can also say that the entries Aij are the entries of the matrix capital A. It seems redundant here, but it'll become. And there's some exercises here that you should go through to make sure it's okay. And here's the definition of equality. If two matrices, if A is the matrix of entries Aij and B is the matrix of entries Bij, they're equal, and we write A equals B when this is true, and that just means they're the same matrix. So, and here's an example of something. If these are the same matrix, then x squared has to equal 1, y minus x has to equal x minus y, 2 equals x plus 1, and y squared equals 1. So this equality of matrices gives you 4 algebraic equations which you could solve for x and y. So there's a sort of a case in which you would use this notation. And sometimes you have different specifications of matrices, and that's why they're useful. Okay, so here's the first application. We have matrices of the same size. We can add them. Can be added and multiply. That's one operation, and the second one is multiplied by a number. So let's say that we have two matrices A and B. And there's a matrix A plus B. You can always add them if they're both size m times n. And what are the entries of this matrix? See, here's where we're saying, okay, what are the entries of the matrix A plus B? Well, they are just Aij plus Bij. So that's what we mean by adding the matrices. It's sort of like addition is just sort of like wholesale addition of all the entries. So, for example, let's say that I had the matrix 2, 3, 4, 5, and I wanted to add that to 1, 7, 3, 8. What that would equal is, first, they're the same size. This is a 2 by 2. This is a 2 by 2. If they weren't equal, I couldn't add them. It's not defined. So I had 2 plus 1 is 3. 3 plus 7 is 10. 4 plus 3 is 7. And 5 plus 8, I think, is 13. So this is the sum. You know, you just add them entry by entry, the corresponding entries. So this is like, this first one here is, A11, this is A12, this is A21, this is A22, because it's like the first index is the row 1, the first index, the 2 here is row 2, the second one is the column 1, column 2, and so you're adding them like this is like B11, B12, B21, B22, and then so over here I was just computing A11 plus B11, and then A12 plus B12, and A21 plus B21, and then A22 plus B22. So the indices are precise, that they lead to sort of things hard to look at because it has so many subscript entries. Just in case of the concern, like if you're in computer science and we're doing this, these indices would be indices of an array. And the way you deal with matrices in a computer science would be as an array of arrays. So these indices here would appear as A square bracket I and B square bracket J, and then I would just have to, if I wanted to sort of deal with this, I'd have to check that these were equal by having a loop that would go over, AI equals BI, and then for a matrix, you'd have like something like AI J. You'd have some notation like this, which would be an array of arrays for computer science. So this isn't that far from the notation that you're familiar with. Okay, well, that's the sum of two matrices. The second operation is we can multiply a matrix by a number. Say if we remember P and we have the matrix A, then the indices of the number times the matrix are just the number times each entry for all entries, for all the entries, for all valid I and J. So, for example, if I wanted to multiply 3 times 7, 2, 5, 6, this is going to equal, well, 3 times 7 is 21, 2 times 3 is 6, 3 times 5 is 15, and 3 sixes is 18. Okay? So I can combine these two operations. For example, here, let's do another one. Maybe what you could, just to practice this, maybe I'll put this down and you can just take a moment and figure it out. 2 times 1, 3, 4, 7, plus 3 times 2, 2, 5, 4. What does that equal? Well, you see, when you multiply this is a 2 by 2, 2 by 2. When you add them, the product by number doesn't change the size. So you can add these, and so they're going to be a size 2 by 2 matrix. So just take a moment and write out what this matrix is. And then I will, when you guys are finished,